Okay, so solving logarithm and exponential equations here. Okay, kind of goes back to things that we've done previously, but we've had to do them on the calculator. Okay, so if you look at the first problem here. Okay, so we have things like this, but we talked about how we do things graphically. So 4 to a power equals 72. Okay, so for example, if we've got one bacteria cell, every hour it quadruples. How many hours is it going to take till we got 72 bacteria cells, basically? Okay, we had to do things on the calculator. Okay, so how do we do that graphically? Anyone remember? How did we do things graphically? Okay, so growth factor, or I mean initial value, growth factor is 4. Okay, if I look at the XY chart, okay, so these are some pretty big numbers here. Okay, so where do we get 72 or more? Okay, so you know it's got to be 3 point something, right? Okay, so now we're going to do more than just kind of guesstimate. Because before, then we would go to the actual graph, and we could, second I could graph y equals 72, find where they cross. Okay? That gets a little time consuming. Okay? So we're not going to do things that way. Okay? So, what's the base of the exponential function? What's the relationship between exponentials and logarithms? Okay, they're opposites, they're inverses. So, we're going to take the log of both sides. Whatever the base of the exponential is, that's the logarithm you have to take. So, this is one of our properties of logarithms back from section 3.3. Okay, what happens if you take a log of an exponential? You're just left with whatever you start with. Yeah, your change of base formula kicks in. So I can do log of 72, or I can do natural log of 72. So natural log of log of the answer divided by log of the base. Okay, someone do this on the calculator for me. So 3 places. Okay, so graphically we said it's got to be 3 point something, right? Okay, so whenever we solve things, we always try to rewrite it in the other form. So if it starts in log form, we want it in exponential. If it's an exponential, here we switched it to the log form. Okay, that's why we talk about, okay, got to be able to convert things just like other classes. We've got got to convert things, slope, intercept, standard, point, slope form. All your linear kind of things in algebra. Same thing here. Or science classes converting from Fahrenheit to Celsius. Just another type of conversion. Okay, and some things they may require us to do a little bit of factoring down the road even. Okay, we'll be bringing in these 3 rules for expanding logarithms down the road here. Okay, so if you look at example 2 here, okay, to me this looks kind of like 3x equals 42, right? What would you do if you were trying to get x by itself? Okay, so first step, divide by 3. What's 42 divided by 3?
14.
Okay, now we've got an exponential. So, take the log of both sides. What's the base?
2.
So we're going to take log to the base 2. That's our logarithm.
Spirit count.
Okay, spirit count?
Wait, do you have a mixed group in here?
Yeah.
So, any
Okay,
sophomores? Is this all juniors and seniors?
there's a couple sophomores.
Oh, sophomores. Where are my sophomores? They have any jammies on? No. Okay, so juniors? Oh, a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Very nice. And then seniors? No seniors and jammies? Okay, thanks.
Yep.
You better than us?
Okay, so once you take the log of both sides, so again, basically, now your change of base formula kicks in. Okay, so there's a reason why we talked about all these different parts and pieces. Now it's all being combined, actually using it like you would if you were in a science career. Okay, so roughly 3.87.
Yeah. Yes.
Okay, so right now these are all exponential ones. Yeah.
I got 3.807.
Yeah.
Yeah, I thought I said 807. I just left it off. Okay, B. Now we're throwing in the other exponential ones. So we always try to get the exponential by itself. So e to the x equals 55. Okay, what's the base? So what type of logarithm?
Natural log.
Yeah, we do the natural log this time. So the logarithm has to match the base. Otherwise, it's not going to come out correctly. Okay, so eventually, once you get that down, okay, some of you may start streamlining things, okay? Because here I know I took the natural log of both sides. Natural log of e to the x is just x, okay? But if you need to, okay, write in that extra step. And then this one, we don't have to do any kind of change of base because we have the natural log button. So just natural log of 55. Okay? Should be 4.007. Do we feel okay with that?
James Johnson, like
First couple ones, they've been fairly cut and dry. Now we're going to start getting a little more involved with things. Okay? So, Where's the exponential? So, get it by itself. Add 4, now we got to divide by 2. So it equals 15 halves. If you want, you can make it 7.5. Okay, what's the base?
3.
Okay, so we're going to take log to the base 3 of both sides. Okay, so just for simplicity's sake, I'm just making it 7.5. So now just basic algebra. Add 5, divide by 2. So, big thing, okay, make sure don't make this 12.5. Every year I see people that want to do that, okay? The 7.5 is part of the logarithm. Okay, so now it becomes a calculator problem. So, 3 decimal places, what do you get?
1.834.
Here's what I found.
1.834? Not quite.
No.
3.417.
Should be 3.417. Okay, so you have to be careful how